Charter Podcast, Episode 11. Code Red for Humanity, Part 3. Renewable Energy, with Dr. Eva Foley, a reader in the School of Mechanical and Aerospace Engineering. Hosted by me, Maurice McCartney. In previous episodes in this series, we looked at how the IPCC report published this year shows we need to urgently move away from fossil fuel emissions if we're to have any chance of slowing already occurring climate breakdown. We then looked at one possible way of making the transition to clean power in the area of transport. But where are we going to get that power from? Well, in this episode, I talked to Dr. Eva Foley to find out.
My name is Dr. Eva Foley. I'm a reader in Queen's University Belfast in the School of Mechanical and Aerospace Engineering. In terms of my work and my research, I've been 12 years in academia. I was 12 years in the private sector, where I worked for multinationals, predominantly in energy, telecoms and pharma projects. And I did my PhD part-time, started in 2007, and I was working full-time and had babies and got married and changed jobs. But I eventually graduated in 2011, which I think was good going. And I did my PhD in University College Cork with actually a Queen's graduate, Dr. Raymond McKeough. And then in terms of the research that I do a lot of power systems. I do, wind power integration. So I look at all the technology. So from heat pumps to hot water, storage tanks, to storage heaters, to air conditioning, chillers, electric vehicles. I do unit commitment modelling, which is basically the grid balancing itself in terms of power generation. So it can be wind, it can be gas plant, it can be anything. That's sort of what I do. I look at gas as well, so gas networks, and another part of my work then as well is wind power forecasting and looking at batteries in electric vehicles. And fuel cells in electric vehicles and how they perform and things like that. So I sort of, it's the full gambit, and I've been doing it for 12 years, really, in essence.
It just sounds like you've got quite a comprehensive overview of the whole clean power and the transition to clean power and the smart grid and all the rest of it. I wondered in context of Northern Ireland, how much electricity have we got to do that? How much clean electricity? Because obviously you can fuel electric vehicles with dirty fuels as well. I mean, so that you haven't really got much further down the road towards clean transport if you're still using electricity that's generated with fossil fuels.
I suppose in terms of the situation, we had a target of 40% renewable electricity consumption by 2020. And we actually achieved that early, that target. And that's, it wasn't a difficult target to achieve in the first place. People may say, oh, it was great, we achieved it. But wind turbines and wind farms are quite easy. Once you have a site and you can develop it, you have your planning permission and you have a grid connection, the technology speaks for itself. It's proven technology. And in terms of, other forms, we're heavily dependent on natural gas. We're too dependent on it, actually, because it's imported natural gas. And we've seen recently there with the price of natural gas increasing, it's going to affect heating prices for people who have natural gas. It's going to affect the commercial sector and the industrial sector who use a lot of gas. Some sectors use a lot of gas, so some industries. And it will also then, usually maybe 9 to 10 months later, it'll hit the power system and electricity prices will go up, because what happens is gas is booked and shipped typically a year in advance for electricity generation, whereas for gas applications and for home use, it's a different market. So the impact of increasing gas prices is felt faster in that sector. In terms of our other targets and where we're going, and what we have is, I suppose, 84% of the renewables we have in the power system are from wind. So wind is a big thing in Northern Ireland. We have about 4% then from solar energy. And then you have a few other bits from landfill gas, biogas and biomass. The problem with wind really for us is we don't have, we've the only storage plant really, sort of the gold label storage plant on the island of Ireland is, it's called Turlock Hill. And, it's a pumped hydro station. And really, for certain grid security activities, you need pump storage. We don't have pump storage in Northern Ireland. Now, there was sites looked at historically, but, and I believe that a tunnel or 2 tunnels were built as part of a development plan for a pumped hydro storage plant, but it stopped its development. And then what we've done is we've installed batteries. So there would have been up in Larne, there's the plant there where they have battery storage, and there's a few other people who are looking at battery storage, and it's part of the DS3. So that's part of the services, ancillary services for the wholesale grid operator. So the ISEM, the integrated single electricity market on the island of Ireland. But the challenge with batteries is they don't offer the same level of system security that, say, a fast responsive internal combustion gas engine will offer, are what the pumped hydro plant will offer. So even though people will say, oh, we need loads of batteries, actually batteries are great, but they can only do certain things. So it's, I suppose, the best way to it's like you're in your kitchen and you have different pots and pans. So the different pots and pans, you have a small pot, you have a steamer, you have a pressure cooker, you have a frying pan, they all do different activities. So I suppose the fast responsive gas turbine, that's like your frying pan to fry your egg. You know what I mean? It's going to be very fast. And then you're going to use your pressure cooker if you want something to cook a little bit faster in a bit of pressure, but you could stick it in the oven and roast it and leave it there for nearly an hour and a half. So that's the way to look at the power system. There's all different parts to it and they all have a different role. And that's the thing about some of the solutions that people are proposing. They don't fully understand the power system in terms of the constraints that we're under, because it's like a pipe, it's like a water pipe. You can only put so much electricity into the network, onto the cable down the line, and we have grid constraints and we have grid congestion over this. So it's just like a water network, or it's like a road, a busy traffic junction. You can only get so much traffic through the junction when it's congested. And that's the issue we face with wind. We can only bring so much of it onto the system currently, and we're spilling wind. So we're dumping some wind. That's the best way to describe it. And people will say,
in one way, we've got more power than we know what to do with. Is what you're saying?
No, we're not actually. We actually, at the moment, we're actually, we have some grid security issues in terms of backup supply, because what happened is certain plants are planned to be mothballed because they don't meet the large combustion plants directive. So there are regulations and guidance in terms to plant and their age in the fleet. And you would have seen it in the Republic of Ireland there recently. They've said, maybe data centres are an issue. We'll have to slow down with the data centres because we can't guarantee system security. So that's the difference between the power system and a road network and a water network. When there's an issue, there's an issue because there's a supply and demand issue, or there may be a shortage of plant. And even a simple thing, you could have 3 plants offline at the same time and the wind doesn't come on the day you expect it. So it's not a case of bringing all wind onto the system. Natural gas is going to play a big role in the power system up as far as 2050. And anybody who says it's not, they're living in a bit of a fantasy planet. And unfortunately, we have to be pragmatic because people have to work and people have to heat their homes and factories have to operate. There's a lot of technology out there, but the problem is if you look at the distribution system, it needs an upgrade. It hasn't been upgraded in 50 years. The transmission system is sort of the wealthy relation of the poor cousin. So the poor cousin is the distribution system. It doesn't get a lot of investment. You go to people's homes. We talk about smart meters. Some people in their homes, their meter boxes are 20, 15, 30 years old, 40 years old. You know what I mean? Now they've been updated, but you still go in, you see an old fuse box. And all of that kind of equipment, there's no business case. So when people talk about electric vehicle charging, there's no business case really for rolling out electric vehicle charging, because how's it going to pay? How's the charger going to pay for itself? They need a new meter. Who's going to pay for the installation? So, we have a lot of hard decisions to make, because what happens is the government makes money from tax on fuel.
Yeah.
So, so how do we balance the books? And that's the problem of the power system. So not alone in the power system, but the financials and the cash flow behind the power system. How do we make it balance? And it's not a case of just basically people using less energy. Okay, that's not how we work as human race, you know. It's about energy efficiency.
Mm-hmm.
So there's a lot of things out there that we could make more efficient using simple improvements. But the problem is, you know, there needs to be a government sort of framework to do it. But the problem is regulation. And how do we regulate? That's really the key challenge. There's no silver bullet solution. You know what I mean? There's no one shoe's going to fit all. It's going to be different for different sectors. And what people think in one sector, we can electrify everything. If you speak to people in the electricity sector, they will say, well, actually, you can't. You know? And that's the different disciplines. And I suppose from my own background, my undergraduate degree is in civil engineering and my master's in transport and my PhD is in power systems. So I'm coming with 3 different voices and I work in mechanical engineering in Queen's. So it has to be interdisciplinary, and that's something we're missing. It's the communication between the disciplines and the fields in engineering. We're very different. We work in very different sort of ways.
How far can we get? How much can we?
I reckon, you know, we'd probably get up to around 70, 80%. You know, if we get to 80% and we are more pragmatic in our technology that we have in the home, in the distribution system, in the transmission system, in using CHP better, in you know, smart metering, the electric vehicle charging, electric storage heaters, all of those technologies play a part. But at the back of it is we need inertia. So this is where then another type of fuel. So we can have green ammonia and green hydrogen come into the system, because those two are actually very interesting in that you can use them in an internal combustion engine. So in other words, you can use them in a power station and they can be your inertia. So we're never going to get completely away from, you know, some sort of gas or fuel, liquid fuel. As I said already, batteries will get us some of the way there, but they're not going to get us all the way there.
So you need a sort of a backstop as the.
Well, it's basically it's V is equal to IR. You can only do so much, and you have to maintain your frequency, so your hertz. So the last thing you want is for the power to be bouncing around in the system. You know.
Tell me this: what if I think sometimes we tend to fixate on sort of the big industrial kind of solutions. You know, you talked about people's houses there and the meters that they have. What if we were to move towards every house being its own sort of little power generator, you know, and having, obviously there are some people who've got solar panels.
They actually, I tell you what, that's a very interesting sort of statement that you've made, because it sounds very easy, but in actuality, what you'll do is you'll cannibalise the wholesale market and you'll cannibalise the retail market. And what will happen is, well, first of all, anyway, the distribution grid wouldn't be up to it. And we have case studies already, whereas in Spain, the government decided to introduce a lot of rooftop solar. And that resulted in, it affected the wholesale market price. It affected transmission system. It affected the distribution system. And in the end, the Spanish government decided they were introducing a solar tax. So if you say to somebody, I'm going to incentivize you to put solar on your roof, how are you going to pay for the power system for industry and commercial use? So, you know, there's a balance to being, you know, maybe in villages and towns and in isolated locations where you have a grid issue already, and they could be a microgrid. But doing it in large urban conurbations like Belfast or Newry, you know, or Bangor, whatever, or Lisburn, it probably isn't the fully correct solution, because already you have a nice grid there in those locations. But maybe going to Enniskillen and looking at a town like that and saying, oh, let's make this a microgrid, that could be interesting. Because what you're doing is you're negating the cost of grid reinforcement, of upgrading and updating the transmission lines in that area. And then you're avoiding your areas of outstanding natural beauty, because people don't want power lines going through areas of outstanding natural beauty. So isolated towns and rural villages, they're probably a better location for your microgrid. And, you know, commercial parks where you could put in maybe some wind turbines. When you go to Spain, actually in Northern Ireland, there's far more standalone commercial auto production, wind turbines than there would be in the Republic of Ireland and parts of England. You'd see it much more here in Northern Ireland, and we've been very good at it. But the issue again is who's going to pay? How do we incentivize it? We've already seen with the supports for electric vehicles, the uptake is predominantly by a certain sector in society. So the people who buy electric vehicles will tend to be better educated and have more money. They're from a different class, social class, than the people who are heavily dependent on a car that may be 10 years old or 8 years old and is a petrol or diesel engine. And they're the people who are more affected by the increases that we're seeing recently in energy, the fuel costs. So that's the thing. How does the government support it? How do they incentivize it? Do they give a tax break? Do they pay people to do it? But if you pay people to do it, then what will happen is you artificially inflate the price of the installation and the equipment. So, trying to find the best solution is always the hardest solution. And that's the work that I do. I look at, and recently I've been looking at incentives for renewable energy up to 2050 to support the Northern Ireland energy strategy for the Department for Economy. And I just finished the report there last week. You could do nothing, but actually do nothing is probably the worst approach, because you're actually going to end up paying a carbon charge, because actually the cheapest solution is always the cheapest equipment. And in this case, it will be natural gas. So wind, solar, CHP, energy storage, what way do we need to innovate the system? And the people who are missing really from the debate is Her Majesty's, it's HMRC. So it's the Revenue Commissioners. So they're the people who need to really be more active in this. It's great to have an energy regulator. It's great to have the Department for Economy, but actually it's the tax take is really the key and the killer in this. How do we get to 2050? So how the price of fuel is going to go up in the next budget probably, because they're going to increase the tax. So if they increase the tax, then there's more money coming into the pot. But then how do we support the renewables? Is that money going to go to the renewables? Is there enough money there? Because, to run the roads in Northern Ireland, it's about $500 million a year. That's how much it is to run the roads in Northern Ireland. So, and another thing as well is, you look at public transport. Northern Ireland, in terms of vehicle ownership, our trips are quite small, like 59%, 50% of people in Belfast commute by car to work. So even though we have around 350,000 smart passes in Northern Ireland, 330,000 of those are held by elderly people. But they're not the people who are commuting into work every day. It's younger people and students. So if you want to get people out of their cars and get them on public transport, maybe they're the people who should get the pass and should be incentivized to use public transport to reduce those transport trips.
So again, there's a lot of politics. You can't escape the politics in terms of talking about a transition to a clean. I mean, even though we began by talking about how to generate clean electricity,
that's easy.
You're almost within 2 steps. You're into the politics of the situation. So
that actually, the technology exists. It's proven. We know what we need to do as engineers, but there's no business case for what we need to do in some of the situations. And the other issue is when governments change and when governments come in and out and politicians come in and out, and we have different energy plans, they have different interests in different local things. It's parish pump politics. Whether you're in England, Scotland, Wales, or Northern Ireland, or in the Republic of Ireland, it's parish pump politics. So, you could have one MEP or one MP or one TD, or one councillor who has an interest in his own area because it's about his vote. And then the other issue is some of the documents that are policy documents, they're actually written on a 4 or a 5 year cycle that really, it doesn't take into account, they should be really written on a 10-year cycle, a 4 or a 5 year cycle for some of these. And they should be updated maybe every 2 or 3 years. So we need to be more proactive. If you look at onshore wind in Northern Ireland at the moment, we're coming to the end of the life cycle of some of those wind farms. They've been around 10 years. They maybe have another 5 or 6 years. But actually, over that 10 years, technology has improved vastly again. and we've larger turbines. Onshore, what we could do, like they're doing in Germany, like they're doing in France, like they're doing in the Netherlands, they're repowering. So what they do is they go to an old wind farm, they take out the turbines that are there, and they put in a new larger turbine. But the issue is noise. So noise and neighbours. And of course, you have some environmental impacts in terms of birds. And some people, what you'll find actually is on many occasions is the people who are from the countryside, country people, they're quite happy to have a wind farm near them. They see it as a job and a revenue stream for if they're a farmer. But actually, it's people who come from urban areas who move into the countryside are the first object, because they moved into the countryside in the first place to get away from noise, to get away from people, to be in the countryside and not to be looking at a wind turbine. So, offshore wind is going to play a huge part. Actually, probably the British Isles could probably supply maybe 30% of electricity needs to the European Union. And I think for us in Northern Ireland, that's a great opportunity. For the rest of the UK and for GB, England, Scotland and Wales, it's a massive opportunity. For the Republic of Ireland, it's indeed huge. It could be part of the European supergrid. What we need really is, if Europe wants to hit its 2050 targets, is for Europe and the power grid and the commissioners in Europe to turn around and say, well, actually, what we're going to do is we're going to do something like they did in the BETA, which is the British Electricity Trading and Tariff Arrangements. That's the GB power system. And we're going to do a contract for differences, which is a European contract for differences for wind, offshore wind, around the British Isles. And they could do the same in Spain, Italy, Portugal, and North Africa for solar. And do another CFD. And that would actually support, once you get the technology going, and after the first 10 years, 9 years, it'll actually pay for itself. So they're the sort of things that we need. And actually, it'll be a massive employment opportunity for Northern Ireland, for the British Isles. North America would be, we'd be ahead of the curve. We already seen what the offshore industry has done in England. Scotland is heading the same way. They're ahead of us. China, Asia, Japan is looking at it. And the good thing about offshore wind is you can put it close to the load, if you know what I'm saying. So it can go near large cities. So Belfast is a coastal city, Dublin, Liverpool. So all of those, and then shipping it over to France on the interconnectors to France. It's a massive opportunity for manufacturing jobs. Like, my dream is to see what they have in Hull, in Belfast, down in the docks, to see that down there, and the shipyard would be a massive manufacturing facility for offshore wind turbines. There was some activity when they were doing a wind farm in the Irish Sea, but that was only assembling. And it would be, we have the skills in Northern Ireland. We're massive in engineering, we're massive in manufacturing, and it would be a shame for us. And we have the best port on the island of Ireland for it. I'm a Cork woman, but I can say, hands on heart, Cork isn't the right port. It's too far away. It's 17. It would take, the distance from Cork to Waterford is nearly the distance from Dublin around past Belfast again. So that's the distance. So in terms of shipping and moving the turbines, servicing the turbines, Belfast Port is the best location on the island of Ireland.
It's a real something for the politicians to take away, I think, and think about. We could be leaders in this field. Yeah. I was also reading a little bit about floating wind farms, which they've started to look at. What is that?
Well, they've been doing research in the EU for that for the last 10 years.
Right.
There's been a few big sort of projects. There's the High Wind project. It's I suppose it's the holy grail of offshore wind. So in terms of industry, what we talk about maybe 50 kilometres offshore and 50 metres deep. And offshore wind floating is that kind of getting out to that kind of boundary limit. A number of the big companies are heavily invested in it. They see it working. Can I put it in context for you? An offshore wind turbine, in terms of size, the rotor or the blade radius, not the diameter, so the radius would be the same length, if not longer, than a Boeing 747. That's an offshore wind turbine. And when we're onshore, typically the turbines are 2.5 megawatts, 2 megawatts, 3 megawatts, you get bigger ones. Offshore, they're now looking at turbines 10 megawatts, 15 megawatts, 20 megawatts. So that's higher than the Petronas towers. That's the kind of thing you're talking about.
It's a major, large-scale engineering.
Yeah.
With all the work and the jobs that go with that.
Huge, and all the steel, it's all welding, you have the drive shaft. So it's mechanical jobs, it's electrical jobs, it's civil engineering jobs for the floating, it's shipping jobs. It's a huge industry. And I think, with our history in Northern Ireland and in Belfast in shipping, we should be, standing out there, waving around and getting action,
Well, let's hope there's some of the political decision makers who are watching us wave, through this podcast.
We should be like Hull. It's reinvigorated Hull in England, and we should be there.
There you are. There's the model to go and have a look at. Maybe I'll have to take my camera over and have a look, make a wee film over there. But in the meantime, that's been very thought-provoking and interesting, and I look forward to picking up some of those themes, perhaps especially the political side of things. That's obviously seems to be key and important.
As I said, and I keep on reiterating, the engineering is no issue. The only issue with engineering is regulation. And when I mean regulation, I mean to do with even simple things like, a guidance document for an electrician. That's the weakness, and that's the only issue in engineering. We have all the technology. The other issue is the business case, but the business case can only come if there's proper political willpower behind it, because investment will only follow when a businessman or a businesswoman are guaranteed a return on their investment and that their numbers stack up.
There you are. I think you've given me plenty of clues to be asking and digging into for later episodes of this series. So
Good.
In the meantime, Dr. Eva Foley, thank you very much.
No problem.
Many thanks to Dr. Aoife Foley of the School of Mechanical and Aerospace Engineering. Follow us on social media at QUB Engagement, and for more in this series, visit our website go.qub.ac.uk/charter-podcast, or subscribe to Queen's University Belfast, the Charter Podcast, on all the main podcast platforms.